Hello and welcome all my dear students. This is Unit 2 P block elements. Today we are going to discuss about diborane and boron trifluoride. The first member is diborane. Now preparation. Industrial production. It is prepared by the action of metal hydride with boron. This already you learnt in the last video. Second preparation is by the action of iodine with sodium borohydride in Diglyme. Here diborane is prepared in small quantities. Actually the Diglyme is a solvent with a high boiling point. The abbreviation of Diglyme is diglycol methyl ether. So the first four letters of diglycol, first letter of methyl, first letter of ether. So it is called Diglyme. Now see the equation. This is sodium borohydride. It is reacting with iodine. Then we are getting diborane. The formula of diborane is B2H6. Now volatile boranes. It is obtained when magnesium boride, when it reacts with hydrochloric acid, a mixture of volatile boranes obtained. The word volatile refers when a substance that vaporizes easily. So the boiling point is very low. Here this is magnesium boride. It is reacting with hydrochloric acid HCl. We are getting higher number of boranes, that is B4H10. This is volatile borane. Properties of diborane. Usually borane are colourless diamagnetic compounds with low thermal stability. But diboranes, they are gases at room temperature with sweet smell. They are extremely toxic. They are also highly reactive. At high temperatures, diborane forms higher number of boranes with liberating of hydrogen. See the equation. B2H6, they are diborane. They forms higher number of boranes with different higher temperatures. So these are higher number of boranes. Next one you see here. This is B2H6 diborane. With different high temperatures, it forms higher number of diboranes. Now the reaction of diborane with water and with alkali. When diborane reacts with water, it is producing boric acid, and when diborane reacts with alkali, it is giving metaborates. See the reaction. This is diborane B2H6. When it reacts with water, that is H2O, we are getting boric acid H3BO3. Also, when diborane reacts with sodium hydroxide, we are getting sodium metaborate. Action of air. At room temperature, pure diborane does not react with air or oxygen, but in the form of impure, it is giving B2O3 along with large amount of heat. That means it is producing heat, hence it is called exothermic reaction. See, this is B2H6 diborane. When it reacts with oxygen, it is giving large amount of heat. So it is called exothermic reaction with B2O3. Reaction of diborane with methyl alcohol. When diborane reacts with methyl alcohol, it is producing trimethyl borate. We can see the reaction. B2H6, this is diborane. When it reacts with methyl alcohol or methanol, that is CH3OH, we are getting trimethyl borate. The formula is BOCH3 3 times. Now hydroboration. Hydroboration, that means when diborane reacts with alkene and alkynes in ether solvent at room temperature, this reaction is called hydroboration. It is used mainly for anti-Markovnikov addition. This Markovnikov addition you already studied in class 11. See the reaction. B2H6 diborane. It is reacting with alkene because this contains double bond. So it is called alkene. In the product you see boron is added. So it is called hydroboration. Next reaction is reaction of diborane with metal hydrides. When treated with metal hydrides, it forms metal borohydrides. See the reaction. This is diborane. Then reaction with metal hydrides. Metal hydrides, it means one metal with hydrogen. So metal hydrides. We are getting borometal hydrides. So this is lithium borohydrides. Another one is sodium borohydrides. Now reaction with ammonia. When diborane is treated with excess of ammonia at low temperature, diborane gives diborane diammonate. Again, it is heating high temperatures, it is giving borazole. We can see the equation. This is diborane B2H6. In the first equation, when it reacting with ammonia at lower temperature, that means below the room temperature, so we are getting diborane diammonate. This is diborane diammonate. Again, when it treated with higher temperatures with ammonia, we are getting borazole. These two structures are called borazole. Structure of diborane. This is very, very important. The formula of borane is BH3. Diborane, it means 2 times of borane. Hence, the formula of diborane is B2H6. This is the point number 1 of the structure. There are 2 BH2 units are there. They are linked by 2 bridged hydrogens. Therefore, it has 8 BH bonds. See the structure. This is the structure of diborane. 2 boron atom in the middle. They are surrounded by 6 hydrogen atoms. You can count in the corner. There are 6 hydrogen atoms are there. You see here, left side 1 BH2 unit, right side 1 BH2 units are there. These 2 BH2 units, they are connected by 2 hydrogen atoms. This is bridged hydrogens. They connect this to boron atom. Okay, so we are getting 8 BH bonds. This is third B boron hydrogen bonds. This is the boron, fourth one boron hydrogen bond. This is the fifth one. This is the sixth boron hydrogen bond. And this is seventh one boron hydrogen bond. And the last boron hydrogen bond, this is. Okay. Point number 2. Diborane has only 12 valence electrons and they are not sufficient to form normal covalent bonds. See the electronic configuration of boron: 1s2, 2s2, 2p1. This 2s2, 2p1 is the valence shell, so it has 3 valence electron. Hydrogen has 1 valence electrons. See the diagram. Each boron atom, they have 3 valence electron and each hydrogen atom, they have 1 valence electron, so that 12 valence electrons are there in the structure. Now point number 3. The 4 terminal BH bonds are normal covalent bonds. That means 2 center 2 electron bond, or you can say 2C bar 2E bond. See the structure. These 4 bonds are called terminal bonds. Then you see there are 2 borons are there. It is called 2 centered, and you can see the bonds. It has 2. Each bond contains 2 electrons, so it is called 2 centered 2 electron bonds. Now point number 4. The remaining 4 electrons have to use it for the bridged bonds. See, out of 12 electrons, 8 electrons were used for boron hydrogen bonds. So then remaining there are 4 electrons are there. So the 2 3-centered boron hydrogen bonds utilize 2 electrons each. Hence these bonds are 3-centered 2 electron bonds. See the structure, you can understand easily. See, there are 8 electrons used for boron hydrogen bonds. Now you see the remaining 4 electrons. So that means 2 electron here, 2 electron here. So it is forming boron hydrogen boron bonds. See here also boron hydrogen boron bonds. See here boron hydrogen boron. This is 3-centered. See here also boron hydrogen boron 3-centered. See the electron, 2 electrons are remaining. Here 2 electron, here also 2 electrons. So hence it is called 3-centered 2 electron bonds. Point number 5. The bridging hydrogen atoms are in a plane. So the boron is sp3 hybridized. See the valence shell 2s2, 2p1 in boron atom. S orbital will contain 2 electrons. P orbital contains only 1 electron. You see the diagram. There are 2 electrons in s orbital, 1 electron in p orbital. So in the excited state, what will happen? Out of 2 electrons in the s orbital, one of the electron will jump to p orbital. See, we will get 4 sp3 hybridized orbitals. Out of 4 sp3 hybridized orbital, 3 orbital will contain half-filled electrons and 1 orbital will be empty. So each electron from the half-filled in boron atom will make a bond with each hydrogen atoms. So boron is sp3 hybridized. Okay. Now point number 6. 3 of the 4 sp3 hybridized orbital contains single electron and the 4th orbital is empty. So already I explained in the diagram. Hope you understood. Now you see the next point. 2 of the half-filled hybridized orbital of each boron overlap with the 2 hydrogen atoms to form 4 terminal 2 centered 2 electron bonds, leaving 1 empty and 1 half-filled hybridized orbital on each boron. See the diagram. Here you see 2 half-filled electron will make a bond with hydrogen atoms and 1 half-filled is there and 1 empty orbital is there. Now 7th point, the BHB bond formation involves overlapping the half-filled hybridized orbital of one boron, the empty hybridized orbital of the other boron and half-filled 1s orbital of the hydrogen atom. See the diagram. One half-filled electron and empty orbital of the boron atom is shown in the diagram. You can understand from the picture. Next we are going to see how the boron hydrogen boron bond is made. So in the boron hydrogen boron, இந்த பாண்ட் எப்படி ஃபார்ம் ஆகுது அப்படின்னா ஒரு சின்ன ஐடியா சொல்கிறேன். இப்போ ஒரு 3 ஸ்டூடெண்ட் இருக்கிறீங்க, அதில் 2 ஸ்டூடெண்ட் லஞ்ச் கொண்டு வந்திருக்கிறீங்க, ஒரு ஸ்டூடெண்ட்டு லஞ்சு கொண்டு வர மறந்துட்டார். அப்போ நீங்கள் என்ன செய்வீங்க, இந்த மற்ற 2 பேர் கூடிய அந்த ஃபுட்டை 3வது யார் ஃபுட்டு கொண்டு வரலையோ அவங்களுக்கு என்ன செய்வீங்க கொடுத்து நீங்கள் ஷேர் பண்ணி 3 பேரும் சாப்பிடுவீங்க. ஸோ அப்போ 3 பேருக்குமே ஃபுட் ஈக்குவலாக கிடைக்கும். அதே கான்செப்ட் தாங்க. இப்போ போரான் ஹைட்ரஜன் இடையில் ஒரு வேக்கண்ட் ஆர்பிட்டல் இருக்குது. அதே மாதிரி போரான் ஹைட்ரஜன் இடையில் 2 எலக்ட்ரான் ஒரு பாண்ட் ஃபார்ம் ஆயிருக்கு. அப்போ இந்த 2 எலக்ட்ரான் என்ன செய்யும் அப்படின்னா இந்த வேக்கண்ட் ஆர்பிட்டலுக்கும் அது ஷேர் பண்ணிக்கணும். ஷேர் பண்ணி போரான் ஹைட்ரஜன் போரான் அப்படிங்கிற அந்த பாண்ட் ஃபார்ம் ஆகும். ஓகே, இப்போ உங்களுக்கு புரிஞ்சுக்கணும்னு நினைக்கிறேன். இப்போ இது பார்த்தீங்கன்னா பனானா ஷேப்பாக இருக்கனால இதை என்ன சொல்லுவாங்கன்னா பனானா பாண்ட் அப்படின்னு சொல்லுவாங்க. ஓகே ஸ்டூடெண்ட்ஸ், நவ் யூசஸ் ஆஃப் diborane. The first use of diborane, it is used as a high energy fuel for propellant. Mainly it is used in the rocket to ignite fire. Second use, it is used as the reducing agent in organic chemistry. Last year you studied about reducing agent and oxidizing agent. Reducing agent, they lose electrons and it is oxidized. Oxidizing agents, they gain electron and it is reduced. Third use, it is used in the welding torches. These welding torches, they mainly used to cut hard metals. You can see in the diagram. Then boron TriFluoride. The formula is BF3. It is prepared. How? Boron TriFluoride is obtained by the treatment of calcium fluoride with boron trioxide in the presence of concentrated sulfuric acid. See the equation. This is boron trioxide B2O3, then calcium fluoride CaF2, then sulfuric acid H2SO4. We will get boron trifluoride. The formula is BF3. Then also it is prepared by treating boron trioxide with carbon and fluorine. See the equation. B2O3 is boron trioxide plus carbon, that is C, next fluorine F2, we will get boron trifluoride BF3. In the laboratory, pure BF3 is prepared by the thermal decomposition of benzene diazonium tetrafluoroborate. See the equation. This is benzene diazonium tetrafluoroborate. The symbol represents heating, so this is called thermal decomposition. We will get boron trifluoride BF3. Then properties. First properties of this boron trifluoride, it has planar geometry, It is an electron deficient compound and accepts electron pairs to form coordinate covalent bonds. Also, they form a complex of the type BX4 minus. See, this is boron trifluoride. When it's reacting with ammonium, that is NH3, it is forming a coordinate covalent bond. So this arrow represents boron accepting electron from the neighboring compound. Next one is hydrolysis. So during hydrolysis, boric acid is obtained. Then again it is converted to fluoroboric acid. See the reaction, boron trifluoride reacting with water, so it is called hydrolysis. So we will get boric acid H3BO3. Again this boric acid H3BO3 plus hydrogen fluoride, we will get fluoroboric acid. It is in the ionic form. So the net equation is boron trifluoride, hydrolysis, we will get boric acid, then fluoroboric acid. This fluoroboric acid, it is in the ionic form. Now uses of boron trifluoride. The first use of boron trifluoride is for preparing HbF4. It is a catalyst in organic chemistry. You know very well about catalyst. Second use, it is also used as the fluorinating reagent. Fluorination is the process of chemically reacting material with fluorine containing compound to produce a desired product. It is mainly used for the industrial application purpose. So today we have completed diborane and boron trifluoride. Hope you understood all the lessons today. So thank you very much. Follow our lessons and complete all the lessons daily. Thank you very much. We will meet in the next video.